Hello class, this is another application of series problems, part 4. I've already tried these two questions and these are actually a lot more difficult, and I'm going to be breaking these up into two separate videos. You can go ahead, pause the video and give these two a go yourselves. Here we go. Oops, let's move this to the second page. And here we go. Now, in a arithmetic series, a geometric series, and you can kind of tell that this is already going to be a geometric series because look at the fourth and sixth term. We want to calculate the sum of this GP. Notice how this geometric progression, it just merely says the sum of this progression. Note how it doesn't tell you to get to the nth term. So it doesn't tell you to sum to the fourth, fifth, or sixth term. It just tells you find the sum of this term. This most likely implies that this is going to be a limiting sum question, which means when we find r, it needs to be less than 1. So it's going to be a fractional or decimal ratio. Here we go. So we are ultimately going to be looking for s of infinity equals a over 1 minus r. So we need to find a and we need to find r. Well, let's begin. The nth term for a geometric progression is a times r to the power of n minus 1. Applying the information that we have, the fourth term is 8 over 9. So t of 4 is going to be a times r. 4 take away 1 is 3 equals 8 over 9. The sixth term is going to be a times r to the power of 6 take away 1, which is 5. It's equal to 8 over 81. Simultaneously solving these, the only way we can do it is by substitution. So I'm going to rearrange the first one to give us a is equal to 8 over 9r cubed. So we divided by r cubed. Taking this expression and substituting it into the next, we get 8 over 9r cubed times r to the power of 5 equals 8 over 81. Hope you can see here. This r cubed can cancel with 5 of them here. So this gives us r squared, which leaves us with 8 over 9r squared is equal to 8 over 81. To get rid of this coefficient, times by 9 divided by 8, we get r squared is equal to 8 over 81 times by 9 divided by 8, which gives us 1 over 9. Taking the square root of both sides, it gives us plus and minus square root of 1 over 9, which should give us square root of a third. So now take note that we have a positive and negative r, which means we'll be most likely having a positive and negative a and a positive and negative limiting sum. So substituting r is equal to plus 1/3 back into here, we get a is equal to 8 over 9. I'm substituting the positive 1/3 r cubed. Now, because I've done this question before on this calculator, you could probably just type this in straight away, but this is not a powerful calculator, so I need to do the denominator first. So that's the denominator. 8 divided by this, so 8 divided by 1/3, we get 24. So the first one we get, a is equal to 24, r is equal to positive 1/3. That's one combination. Testing at the negative now. Just going to duplicate this. And let's move this around a little bit. Negative. There we go. So let's get rid of this. You know what? Just do it again. So 9 times negative 1/3 cubed. Negative 1/3. So 8 divided by this answer here. We get negative 24. This gives us A is equal to negative 24 and R is equal to negative 1/3. Now that we have both A and R for both positive and negative, we're going to resubstitute both. I'm just going to duplicate this. And we're going to substitute both combinations into our limiting sum here. So substituting in the positive, S infinity, 24 over 1 minus 1/3. And for the negative, equal to negative 24 over 1 minus 1/3. Once again, for your calculators, you could probably just substitute it all in one go, each one. But for mine, let's see how it turns out. 24 divided by 1 minus 1/3 and negative 24 over 1 minus 1/3. Hope this works. There we go. Excellent. So we get positive 36 and negative 18. So these are our two possible answers. Just from what I've practiced with this video, the next one's going to take quite a long time, so I'm going to cut it short here. Hope that gave you an insight into this particular question. Hope to see you in the next one here. Best of luck.